Hello students, welcome to the chapter Coordination Compounds. Let us begin with a new topic, that is denticity. To understand denticity, here I have an example. So if you see here, we have COOH connected to COOH, which is called as oxalic acid. Now since it is an acid, so it must donate H plus ions. Here it is giving H plus ions and therefore you get COO negative, COO negative. That means the two oxygen here has a lone pair of electrons which it can donate. So it is acting as a Lewis base. So if I consider a metal here, can I say that both the oxygen atoms, they can form coordinate bonds with the metal. Now this oxalic acid is a ligand here, and how many bonds is this oxalic acid making with the metal? 2 bonds. So therefore it is called as, since it is forming 2 coordinate bonds, it is called as bidentate ligand. Now what exactly is the term bidentate ligand representing? Bi means 2. So if you see here, it is forming 2 coordinate bonds. Dentate comes from the word denticity. What is denticity? Denticity refers to the number of donor groups in a single ligand that binds to a central atom in a coordination complex. So in this particular ligand, there are 2 donor groups, that is 2 oxygen binding to a single metal in a coordination complex, and therefore the denticity here becomes bidentate. Let us take another example. This is your glycinate ion. In this case, again if you observe, we have 2 donor groups. One is nitrogen, another is your oxygen. So if I take a metal here, nitrogen can donate the lone pair and forms 1 coordinate bond. Similarly, the oxygen will also donate and forms another coordinate bond. So in this case also, there are 2 coordinate bond formed, and therefore this is also didentate, or I can say a bidentate ligand. Now the next one is, as we already know, to find out the denticity, we just need to see how many donor groups are present, or I can say how many coordinate bonds will be formed. So here I have a question where you have to find the denticity. The question is here, if you see in this particular ligand, there are 3 donor atoms, that is 3 nitrogen, 1, 2 and 3. So since there are 3 donor groups, so 3 coordinate bonds will be formed, and therefore it is called as a tridentate ligand. Let us try to name this. In this particular ligand, you have CH2, which represents ethylene. We have 2 such, that means it is a diethylene. Now NH2 is called as amine. So how many amine do I have? 1, 2 and 3. So the name becomes, for CH2 we'll write ethylene, and for NH2 we write amine. But before naming this, one very important note. Whenever you are writing the ligand amine, NH3, in inorganic chemistry, we always write the spelling to be AMMINE, but if it is present with any alkyl or aryl group, then we use a single M. So let us now name this. It is diethylene triamine. If you note here, the spelling is containing only one M. That means it is related to an alkyl or aryl group. Moving ahead, the next example. Let us try to find out the denticity by counting the number of donor groups. So in this case, you have 1 nitrogen, 2nd nitrogen, 1 oxygen, 2nd, 3rd and 4th. That means total donor groups here become 6, and therefore it is a hexadentate ligand. Let us try to name this now. This is your ethylene. Then comes, we have amine, 2 amines, it will be diamine. CH2COO negative is called as tetraacetate ion. Why tetra? Because there are 4 acetate ion. So the name becomes ethylene diamine tetraacetate ion. So that is how you can find the denticity of any given ligand. That's all for this module. Thank you.